Hi, kids. Hey, I'm going to talk about a series circuit. All right, and series circuit rules. Physicists, we pick names that are stupidly obvious because we're not, I guess, the most creative people there ever was. So if we say if you have a series circuit, why is it called a series circuit? Because the resistors are in series, one right after the other. So a series circuit would look something like this. Okay. You will notice those resistors are in series one after another, which tells you one of the big main rules of a series circuit. A series circuit only has one path. Okay, super duper duper important. By the way, my phone thought I was talking to her because I was talking about series. Anyway, all right, but there's only one path. Because there is only one path, okay, that we know that there are no junctions. Well, that means if I label some random points here in my circuit, that means that the current flowing here has to be the same as going through this resistor, and the same as going through here, and going through there, and going through there. So in a series circuit, because there is only one path, current is the same everywhere in a given circuit. Now, please be careful, okay? If I was to say, hey, I have a circuit like this, the current everywhere in this circuit is the same. The current everywhere in this circuit is the same, but it doesn't mean that the current in this circuit and this circuit are the same. Okay, the current everywhere is the same. This is your junction rule. There is no junction, so therefore the current has to be the same. Okay? If you think about your loop rule equation, well, if you do this around, well, any loop that you take around, the voltage has to add up. Well, the voltage here has to be equal to this plus this plus this plus this, because there's only one volt. There's only one. Well, not that, but there's only one loop. So there's one rule. There's an important thing. But if you think about loop rule, voltage. Okay, voltage will add up. Okay, and again, this should be something you don't have to memorize because you understand the loop rule. So my total voltage is going to equal V1 plus V2 plus V3. If this is R1, R2, R3. So V total would equal V1 plus V2 plus V3. Okay. Well, if you take a look, if I know that V equals IR, so I can sub this in and say, well, IT times RT equals I1 times R1 plus I2 times R2 plus I3 times R3, and so on. But we already said the current everywhere is the same. So really, I don't need these little subscripts because the current everywhere is the same. Well, if the current everywhere is the same, I can do this, and lo and behold, I end up with RT equals R1 plus R2 plus R3. Meaning, to find the total resistance in a series circuit, you have to add them up. Add up all the individual resistors. Okay? And then, honestly, power is going to add up, but power will always add up. So power adds. Okay, so that means the total power equals the power for 1 plus power for 2 plus power for 3, and so on. Which again should make sense because if I multiply this times I would get I. Do you see power, 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 power? Which means it has to add up. Okie doke. Those are the basic rules for series circuits. There are other things that should make sense, like, hey, you know what? If I break my circuit, do you see how everything turns off? Have you ever had, horrible holiday lights that, you go and you plug it in and the whole stupid strand turns off because one bulb burnt out? That's a series circuit. Okay. There you go. Hopefully that makes sense. Bye, kids.